My name's Scott. I'm a production engineer at Shopify, and today I'm going to talk about how we used NGINX and Lua to build an HTTP request router. So, first of all, I work for a company called Shopify. Some people confuse that with Spotify, but Shopify is two different companies. We're a commerce platform. We have over 165,000 merchants. We offer an online store as well as offline channels for merchants that want to sell products. We have a website builder. We do order management. We do payment gateways. We aim to provide everything that you need as a merchant to run your business. The idea is if you have a great idea for a product, you can sign up for a Shopify account, and within 30 minutes, your online store is up and running, and you can be making sales and making money. We've been growing at a really fast pace, and scaling our backend to keep up with our growth has been a constant technical challenge for us. So some quick stats. We currently do about 300 million unique visitors per month. Average response time around 70 milliseconds. Our platform can currently handle around 10,000 checkouts per minute, and the core Shopify application is running in 3 separate data centers. So Shopify is a multi-tenant Rails application. All of our requests are processed by a single pool of application servers per data center. It's one of the oldest Rails applications in the world. Some of the first commits are from 2005. We're also one of the largest Rails applications in the world as well. We use MySQL as our persistent data store. One of our major engineering efforts in 2013 was to migrate from a single MySQL instance to a sharded architecture, allowing us to scale horizontally. And we use Redis and Memcache for caching things. We use Elasticsearch for search, and then finally, of course, we use NGINX. And NGINX actually plays a crucial role in Shopify's infrastructure. So this is a really high-level diagram of Shopify architecture. You can see that you've got the interwebs, and requests come in through our traffic scrubbing layer, then on through our NGINX load balancers to our application servers. And we have some requests that may end up in queuing jobs, and those get processed by a pool of job servers. So after moving Shopify to the sharded database architecture, the next kind of major initiative for production engineering was growing out a second data center. Up until we had done this, Shopify existed as a single data center in Chicago. We'd kind of grown the platform organically. We had racks and servers spread throughout this data center in multiple cages, and building a second data center really allowed us to do things right and construct a proper network architecture right from the get-go. It also gave us a story for disaster recovery. So for us, downtime costs our merchants money, and we don't want our merchants to lose money. So we needed a plan to come up with to bring the second data center online with the least amount of downtime for our merchants. And when we were doing all of this work, we didn't want to do the big bang rollout as we heard about this morning. We wanted to have a way to kind of incrementally make these changes and make sure that the system was tested adequately before we actually did the full data center failover. So this is kind of the very similar to the diagram that I showed previously, but it also includes the Ashburn data center that we have on the right-hand side. One detail that's kind of important on this diagram is there's a line connecting the load balancers between the Chicago and the Ashburn data centers. And what that line represents is the request router that we built called Sorting Hat. So Some of you may be Harry Potter fans, and you might know that Sorting Hat is the magical hat that determines which house a new Hogwarts student will be assigned to. So in our case, Sorting Hat is the piece of software that we use to determine where an HTTP request will get routed. So at the core, Sorting Hat is really a pretty simple system. You have an HTTP request, it comes into NGINX. Sorting Hat looks at the destination hostname. It queries a MySQL database to find the associated shard that the request is destined for. And then using that shard, we determine what data center the request will be routed to. So Sorting Hat has this internal mapping that maps shard to data center, and that mapping can be updated dynamically without us having to restart NGINX. So then using the response that we get back from MySQL, we just forward the request on to the appropriate data center. So what was interesting for us with Sorting Hat is it was the first time that we had really developed infrastructure as an application. And in doing that, we wanted to follow kind of the same principles that we use for developing software in the Shopify core application. So, doing things like continuous integration, doing very small iterations, adding small features and deploying often, code reviews, trying to keep things simple and just keep everything as simple as possible. Testing infrastructure is really critical. Oftentimes I find overlooked. And one of the things that we did when developing Sorting Hat was we started writing tests right from the get-go. And also, continuous delivery is really important for us. We like to be in a state where the code is always ready to be deployed and can be deployed, and we should be deploying often. And also, you should have kind of safety nets in place to ensure that if things go bad, you can roll back really quickly and easily. So Shopify we use Chef for infrastructure provisioning. And for the past couple of years, we've been using Vagrant in development. But one of the things that may be a little bit unconventional is that we actually provision our Vagrant developer instances using our production Chef cookbooks. So this has a couple of advantages for us. Really, one really nice thing is that it brings our development environment closer to production. So all of our developers use Macs, but we use Linux in production. But by using Vagrant and Linux and Vagrant, we can run Shopify on the same operating system using the same software that we use in production. We can also use that in development. Another nice advantage of this is it tests our cookbooks as well. There have been a couple of occasions where a cookbook change, you might be working on something in cookbooks that may have broken in production, but by testing it first in Vagrant, you ensure that everything is all good. So because we had a lot of success with this environment in developing the Shopify core application, we also use it as a base for starting to work on Sorting Hat. So there are a lot of examples of NGINX Lua code around on the internet. A lot of those examples are kind of just blobs of code that are part of an NGINX config file. Really just code snippets that aren't really intended to be used, I would imagine, in a larger application. So as Ruby and Rails developers, we came into doing NGINX and Lua development with a very Ruby on Rails mindset. So what we ended up doing was creating we created a middleware layer essentially for Lua. What we found was that in writing Sorting Hat, there was other functionality that we needed outside of just request routing that would fit well in NGINX. So we built this middleware layer that allows us to create these Lua modules that we can just chain together. Ruby has a middleware library called Rack, and Rack, it gives you a really simple interface for writing these middlewares. You essentially have to implement a single method called call, and that method takes an environment parameter and it returns a response code with response headers and the response body. So what we did was we defined our own middleware interface, kind of in the spirit of Rack. And for us, all a middleware is a Lua module that defines one. It defines one method, also named call. So the idea here is that the call method gets invoked during an NGINX request phase, and you can register these middlewares to participate in any part of the NGINX request phase kind of pipeline, and you can also kind of configure the order in which these middlewares will be called. All of this configuration is done through Chef, and it works really, really well for us. So some of the example middlewares that we built, we have middlewares to do request ID generation. We do Kafka logging. We have a really simple ping middleware, and we have this little middleware that we called HTTPDB, which is a total mouthful. And we use that as kind of an in-memory key value store with NGINX. So this is a really simple, this is the ping middleware, actually what we're using today in production, and it just kind of shows how easy it is to write code that runs in NGINX. So just to simply walk through the code, the first line just defines a new table in Lua, and then we define a call function. And the conditional at the beginning of the function just checks to see if the request method is get, and if the URI is pointing to services ping, then all we're going to do is set the content type to text plain in the response, and send back the message pong, and finally return HTTP OK. And really, that's pretty much it. It's really quite simple. So the next thing I wanted to talk about is resiliency and testing. When you're writing code on the front-end load balancers, you really need to make sure that you're testing failure scenarios. Resiliency is truly paramount here for us. This is code that's going to be executing on every request that comes into the Shopify platform, so it needs to be highly resilient to failure. Testing is also extremely important. So not only do we need to be thinking about resiliency, but we also need to be doing as much as we can to test these failure scenarios in development and not in production. So we're big fans of integration testing. When we first started working on Sorting Hat, we wrote a large number of unit tests in Lua, but we found that we ended up writing so much mocking code that the tests became more of a burden than a benefit, really. AgentZH, the author of OpenResty, he wrote a test NGINX package that can be used for integration testing, and it's pretty good. But ultimately, we're Ruby developers, and we ended up writing our own integration testing framework in Ruby. So this is just a little snippet of a real test that we have as part of our test suite. It really does a lot of things, even though it's only 5 lines of code. What the first line does, the start NGINX statement, that actually spins up an NGINX process and waits for it to become available before returning. And the parameter that gets passed to it is the name of a configuration file that's part of our test fixtures, and that defines the configuration that NGINX process is going to use. The second line starts up a simple rack server that will respond to a request with the response of hello world. And then the third line is what actually submits the request to the server. So it does an HTTP GET to the /single upstream server endpoint. And then finally, the fourth and fifth lines, they just assert that the responses are what we would expect. We expect that the response code is going to be 200, and we expect that the body of the request or the response is going to read hello world. So using this integration testing framework, we can really write a lot of high quality tests. So on kind of the resiliency front, one of the resiliency patterns that we really leverage extensively in Shopify is called the circuit breaker. So the idea behind a circuit breaker is you retreat an external resource. In our case with Sorting Hat, the MySQL server, you treat that resource as kind of a circuit. And in the ideal case, the circuit is closed. But after a certain number of failures, you want the circuit to open so that you're no longer going to try to talk to that talk to that resource for a given amount of time. So where this is really advantageous is when a resource is slow or if it's down. So for example, if MySQL starts taking longer than 500 milliseconds to respond, we're just going to open the circuit and we're not going to talk to it for a while. And really what kind of works along with the circuit breaker is having a proper resiliency fallback, like fallback behavior. So in our case, we have caches that we'll use to cache the shards for a given host name, so that even if MySQL is down, in most cases that the destination shard and the destination data center would be cached, so we wouldn't necessarily fail the request. So one of the other tools that we built is called Toxiproxy. And Toxiproxy, it's a framework that we built at Shopify to test different network conditions in for both development and test. It's just it's basically a TCP proxy that we wrote in Go. We have Toxiproxy clients, and they communicate with the Go service using an HTTP API, and through that you can manipulate different network conditions. There are clients written for a whole bunch of different languages, Ruby, Go, .NET, and it's really quite easy to build clients for languages that we haven't actually supported yet. So the cool thing about Toxiproxy is you use it to wrap a section of code in a toxic, and what a toxic represents is a bad network condition. So it could be something like high latency, you could simulate a down endpoint, you could simulate low bandwidth, and the idea is that all of the code executing within that block will experience the network conditions as defined by the toxic. So we use this throughout Shopify to test various failure scenarios, and we're also using it to test Sorting Hat. So this is another simple test that we have that shows how we test with Toxiproxy. So in this case, in the first block of code, we're getting the / endpoint, and we're asserting that request was routed successfully. But the difference here is in the second block of code, we wrap the first block in a Toxiproxy down toxic. So what this is going to do is it's going to simulate the down condition for a MySQL server. So really, when the request gets to NGINX, it's not going to be able to talk to the destination MySQL server. And what we're doing here is we're asserting that the request number one succeeded, and number two that it returned cached data. So talked a bit about development, and testing and whatnot. Now I'm going to talk about how we actually put Sorting Hat into production. So Shopify has this great tool that we built called ShipIt, and it's an open source tool that we built in house, and we actually use to deploy Shopify currently 20 to 30 times a day. What's great about ShipIt is that it allows anybody within your organization to deploy. It makes deploys not be just like an operations thing where you have to do a Capistrano deploy or whatever. You have this really pretty web UI where you can just click the deploy button and it rolls out code. The other nice thing is that you can roll back easily as well. If you notice things are going bad, you click the rollback button and we'll roll back to the previous revision. One of the other great things about ShipIt is that because it responds to GitHub webhooks, we can actually use it for continuous deployment. So what that means is essentially whenever a new commit is merged into the master branch, ShipIt will just automatically pick it up and roll that code out to production. So this is the actual tool that we're using to deploy Sorting Hat, and it's working out really, really well for us. So before actually getting it into production, we made sure that we set up proper monitoring. We want to know immediately whenever something's wrong. Again, this is the front door to Shopify. Every request is going to be going through this code. So we want to make sure that we know if something ever does go wrong. So what we did was wrote a little statsd module in Lua, and that feeds NGINX and Sorting Hat metrics into Datadog, which is what we use for monitoring. So this slide has 4 example graphs that we use to monitor production. The interesting thing about the top, I guess the one on the top left, that shows the average request time in Sorting Hat. When we initially built this graph, we were measuring in milliseconds, and all of the values that we were seeing were 0, and we're like, what's going on? This can't be right. Like, did we make a mistake? And it turned out that we just were in the wrong scale, and we needed to measure in microseconds instead. So after changing the scale, we finally started to see these non-zero values, and really it's kind of a testament to both NGINX and Lua and LuaJIT, just that it is that fast. We also have different types of alerts set up. So really, like if we'll get alerted if circuits are open, we'll get alerted when throughput drops below a certain level. We really wanted to make sure that all of our monitoring and alerting was kind of there before we rolled this thing out. So leading into the data center move, leading into that, one of the things that we wanted to do right away was make sure that we got Sorting Hat into production. Even though it wasn't actually doing anything, it was important for us to get confidence that that the code was deployed and that it was working, and then we could slowly add new functionality as we went along. So yeah, that was really a strong thing for us. We had a really great deployment story with ShipIt. It was really easy to deploy new code, really easy to roll back. One of the great things about NGINX we found was its resiliency to invalid configuration. Like, even if you make a mistake, you have a typo in your config, or you write some bad Lua code, the NGINX reload will fail. But even though the reload fails, it still keeps the existing workers alive. I remember a couple of stressed moments when this happened, and people were like, "Oh my God, is Shopify down?" But no, everything is fine. One of the other really important things that we did was weekly practice drills. So to practice, what we were doing was taking a test shard and moving that test shard between data centers, and we would do this once a week for about 2 months. So what this did is it gave us confidence that we were moving in the right direction and that we weren't breaking things, and really practice makes perfect. So finally, the big day came, and we did this move from moving from our Chicago data center to the new data center in Virginia, and everything actually worked just as expected. It worked really better than expected. We were able to switch traffic kind of in one quick step. You can see the graph on the left shows the traffic moving from the Chicago data center and then over to the data center in Virginia. And to our merchants and users that were browsing Shopify stores, they really saw zero downtime. Like, it was totally seamless for them. So it was really a great success. So I've gone through kind of a lot here, but if there's anything to kind of take away from this talk, I would say that it's these three things. When building infrastructure, it's really important to follow good software development practices. I guess this means kind of doing things the DevOps sort of way, which is something that we've started to embrace at Shopify. Testing and resiliency are really crucial when writing infrastructure code, especially code that's running on a load balancer. For us, this is probably, Sorting Hat is really the most well-tested code, I would say, in the entire Shopify stack. And yeah, you really have to think about those failure scenarios. And finally, you want to iterate fast, and you want to iterate often. You want to roll out your features incrementally, and you don't want to do this big bang approach to rolling out big infrastructure changes. So we've had really a lot of great experience with NGINX and Lua, and we're super excited for the future. We see NGINX and Lua as being kind of the foundation for point of presence servers, and I'm actually excited to see the talk, I think by Dropbox today, about how they're doing edge routing with NGINX, because that's something that we're actually looking at doing at Shopify. We are looking at writing a whole bunch more middlewares. We're thinking about doing load balancing from middlewares. We're looking at doing connection throttling, page caching. There's so many really interesting things that you can do with NGINX and Lua. And finally, we want to contribute back to the community. Shopify is very big on open source, and we really think that some of the stuff that we're working on is really cool and could benefit a lot of others as well. So that's really all I have today. Hope you guys enjoyed it. Thanks. Are there any questions?
Is there any reason you're not storing the shard ID in verifying that?
So the question is there any reason why we're not? Sorry, what was it?
Is there a reason you're not storing the shard ID in an encrypted header and verifying it via HMAC?
Yeah. So is there any reason why we're not storing the shard ID in an encrypted header and then verifying it via HMAC? Really, no, because the load balancers and the app servers that are actually consuming the shard ID are on the same network, so we're trusting that, like when the request comes into Sorting Hat, we strip any shard ID headers that could be set by the client. So we're trusting that the load balancer isn't, like the request between the load balancer and the app server is not going to be tampered with because it's running within our own data center. Is that not? Oh, I see. So store the. I guess there's still the issue of you have to look it up at least once. Like if the client doesn't have a cookie that's storing that shard ID header, you still have to look it up at the first time the client hits the site, right? But yeah. Yep. So the question is, what would happen if you accidentally misroute traffic, like sending it to the wrong shard? What usually happens is the request would fail with a 500. Before we deployed this, we had a lot of testing to make sure that we weren't doing that. So what we would do is, when I said that we rolled it out slowly and it wasn't doing anything, what we were doing was setting the headers where we thought the request would be routed, and we sent that to the upstreams, and then the upstreams would validate that was in fact the correct route to pick. And then whenever there was a mismatch, that would be logged, and then we could take action on that. So I guess you're asking, like, how do we balance, like, what shops go on what shards? Right, so we actually have a shard, like a shop mover tool that allows us to move shops between shards. So if we notice that one shop is doing, say, there's big flash sales on one shop that's consuming a lot of capacity, then we can actually move that shop over to another shard. We don't have this set up in an automated way right now, but it's something that we're looking at doing in the future. Yeah. So in the middleware slide, I actually showed that there were two functions. There was call and init worker, and I didn't explain what init worker does. So init worker is intended to be used for background tasks. One thing that we use it for is for statsd monitoring. So what the init worker does in some middlewares is it spawns a timer that can then be used to dump metrics into statsd. Yep. So the question was, any tips and tricks for writing NGINX and Lua code? Really test and test for real. Like I mentioned before, with doing unit testing and doing a lot of mocking, one thing that we found was sometimes our mocks were doing the wrong thing, and we got a lot of benefit by building real integration tests and testing against the proper, like NGINX proper, and making sure that it would do the right thing. That was actually a real gotcha for us, is make sure that you're testing against the real thing. Yeah, so the question is, do we use LuaJIT? We do use LuaJIT. Right now we're using 2.0. We'll probably upgrade to 2.1 sometime in the future, in the near future, I would imagine. But LuaJIT has been great for us. We've never had any problems with it. It's a really great piece of software. Yep. So the question was, what kind of logging do we use inside Lua? So in the Lua code itself, we use the NGINX log statement to log out to static log files, and then we use internally we use Splunk to aggregate all of our log data. Any more questions? All right. Well, thanks everyone. I'll be around if anybody has any other questions. Thank you.